The Foundations of Geometry by David Hilbert.
Chapter 4, The Theory of Plane Areas. Section 18, Equal Area and Equal Content of Polygons.
We shall base the investigations of the present chapter upon the same axioms as were made use of in the last chapter, sections 13 through 17, namely, upon the plane axioms of all of the groups with the single exception of the axiom of Archimedes. This involves then the axioms group 1, 1 through 2, and groups 2 through 4. The theory of proportion, as developed in sections 13 through 17, together with the algebra of segments introduced in the same chapter, puts us now in a position to establish Euclid's theory of areas by means of the axioms already mentioned. That is to say, for the plane geometry, and that independently of the axiom of Archimedes. Since by the development given in the last chapter, pages 23 through 35, the theory of proportion was made to depend essentially upon Pascal's theorem, Theorem 21. The same may then be said here of the theory of areas. This manner of establishing the theory of areas seems to me a very remarkable application of Pascal's theorem to elementary geometry. If we join 2 points of a polygon P by any arbitrary broken line lying entirely within the polygon, we shall obtain 2 new polygons, P sub 1 and P sub 2, whose interior points all lie within P. We say that P is decomposed into P sub 1 and P sub 2, or that the polygon P is composed of P sub 1 and P sub 2. Definition: 2 polygons are said to be of equal area when they can be decomposed into a finite number of triangles which are respectively congruent to one another in pairs. Definition: 2 polygons are said to be of equal content when it is possible, by the addition of other polygons having equal area, to obtain 2 resulting polygons having equal area. From these definitions, it follows at once that by combining polygons having equal area, we obtain as a result polygons having equal area. However, if from polygons having equal area, we take polygons having equal area, we obtain polygons which are of equal content. Furthermore, we have the following propositions. Theorem 24. If each of 2 polygons, P sub 1 and P sub 2, is of equal area to a third polygon, P sub 3, then P sub 1 and P sub 2 are themselves of equal area. If each of the 2 polygons is of equal content to a third, then they are themselves of equal content. Proof. By hypothesis, we can decompose each of the polygons P sub 1 and P sub 2 into such a system of triangles that any triangle of either of these systems will be congruent to the corresponding triangles of a system into which P sub 3 may be decomposed. If we consider simultaneously the 2 decompositions of P3, we see that, in general, each triangle of one decomposition is broken up into polygons by the segments which belong to the other decomposition. Let us add to these segments a sufficient number of others to reduce each of these polygons to triangles, and apply the 2 resulting methods of decompositions to P sub 1 and P sub 2, thus breaking them up into corresponding triangles. Then, evidently, the 2 polygons, P sub 1 and P sub 2, are each decomposed into the same number of triangles, which are, respectively, congruent in pairs. Consequently, the 2 polygons are, by definition, of equal area. Proof of the second part of the theorem follows without difficulty. We define in the usual manner the terms rectangle, base, and height of a parallelogram, base and height of a triangle. The Foundations of Geometry by David Hilbert.
The material contained in the following translation was given in substance by Professor Hilbert as a course of lectures on Euclidean geometry at the University of Göttingen during the winter semester of 1898 and 1899. It was translated by E. J. Townsend, Ph.D., University of Illinois. The text was downloaded from Project Gutenberg with the following notice: this ebook is for the use of anyone, anywhere in the United States and most other parts of the world at no cost and with almost no restrictions whatsoever. Read by Jim Renholt. Programming and illustrations by Jim Renholt. 2019. Portrait of David Hilbert by Rita Ray Renholt. Thank you for listening.